بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 4.3 Simplex method maximizing problem. Consider the constraint inequalities to convert the constraint inequalities to equations containing slack variables. So we studied in the section how to change the inequality to a slack variable. We write it 3x plus 5y plus s1 equals 15. So this is the slack variable that represents the difference between 3x plus 5y and 15. And for the second inequality, we also introduce another slack variable. So 3x plus 6y plus s2 would be equal to 20. In these exercises, set up the Simplex matrix used to solve each linear programming problem. This is the first step. In task A, we set up the Simplex matrix. And to set up the Simplex matrix, we first introduce the slack variables. So we change each inequality to an equation. So we write it 2x plus 5y plus s1 equals 400 and x plus 2y plus s2 equals 175. And the objective function, we take the right hand side to the left hand side and write it negative 3x minus 7y plus f equals to 0. And now we set up the matrix, the Simplex matrix. We write the coefficients of x in the first column, 2, 1, and negative 3. The coefficients of y, 5, 2, and then negative 7. The coefficients of slack variable 1, S1. S1 appears only in the first equation. So the coefficient of S1 in the second equation is 0, and also in the objective equation is 0. And now the coefficients of S2, there is no S2 in the first equation, but the coefficient of S2 is 1 in the second equation. Now the coefficients of F, there is no F here, no F here, and the coefficient of F is 1 in the objective equation. And we make this line and this line horizontal and vertical lines, and we then put the right hand side of the equations 400, 175, and 0. This is called the Simplex matrix or the initial Simplex matrix. We do the same here, but we have three variables. So 2x plus 7y plus 9z plus s1 would be equal to 100, and 6x plus 5y plus z plus s2 is equal to 145. X plus 2y plus 7z plus s3 is equal to 90. And we move the right hand side of the objective function to the left hand side, negative 2z plus f equals to 0. And the matrix would be, we put coefficients of x, coefficients of y, coefficients of z, coefficients of s1, coefficients of s2, coefficients of s3. In the third equation, we have s3. Coefficients of f and the right hand side. you always notice that in the initial simplex matrix, we have always the identity matrix here, I4, for example. Here we have I3, and that happens always in the initial simplex matrix. Also notice that how many inequalities we have. We have three inequalities. So we introduce three slack variables. So you understand that there are three slack variables and three variables in this example. Here, a simplex matrix is given in which the solution is complete. So this is the final simplex matrix. Identify the maximum value of f and the set of values of the variables that gives the maximum value. So from the matrix, this is a final matrix. We know that it's final because all the indicators are positive, are non-negative. All the indicators, these numbers are the indicators are non-negative. So we can immediately uh, here this is f, it has coefficient 1. So we can read that the maximum value of f is 1, uh, and a set of values of the variables. Okay, at now here these are the coefficients of x, and x is 1 here. So x is a basic variable and it's equal to 11. The value of x is 11. And y is also a basic variable and its value is 9. While s1 is non-basic and s2 are also non-basic, so we give them the values of zeros. So I wrote the maximum value is 1. I mean, the maximum value of f is 20. This is the maximum value of f. So this is the answer of the question. Here I have three inequalities. So these are the coefficients of f, and I have three slack variables. So here S1, S2, and S3. And I also have three variables. The basic variables here are y, z, so y is basic, z is basic, and s1 is basic because 1 and elsewhere zeros, while x is non-basic and s2, s3 are non-basic. So the maximum value of f is 525. X is non-basic, so it's equal to 0. Y is basic, and this is 1, so it's equal to 14. Z is basic, and this is the 1, so it's equal to 11. And S1 is basic, and its value is 6. S2 is 0, and S3 is 0. They are non-basic variables. Here, a simplex matrix for a standard maximization problem is given. So it may be final matrix or not. Write the values of all the variables and of the objective function. So here, for this simplex matrix, it is not complete because we have a negative number here, -6. But we can say that the maximum, not the maximum, still not finished, but the value of f here up to now is 75. And we can see that we have two equations. So we have two slack variables and two variables. And we can see that x is non-basic. So it takes the value of 0. Y is basic. It takes the value of 45 because the 1 is here. S1 is basic and it takes the value of 14. S2 is non-basic and takes the value of 0. So these are the values of all the variables. B, indicate whether the solution is not complete. Not complete. Indicate whether it's complete or not complete. Not complete because there is a negative sign. If the solution is not complete, find the next pivot. To find the next pivot, this is the pivot column. This is the pivot column, the first column. And the pivot row, we divide 14 by 2, and the answer is 7. And divide 45 by 3, and the answer is 15. 7 is less than 15. So this is the pivot row, and 2 is the pivot element. Find the next pivot. So pivot element is 2 in column 1, and let me write column 1 and row 1. Okay, and then make other entries in the pivot column equal to 0. Find the next pivot and state all row operations with that pivot. Okay, so we need the row operations that make x basic variable, that makes the 2 1. So half are 1. This is the first operation. This will make 2 1. Then we use it. We use the 1 which we have to make the 3 0. So negative 3R1 plus R2. And we need to make the negative 6 0. So 6R1 plus R3. Do not perform the row operations. Here, first we find the values of the variables. How many inequalities? We have 3 inequalities. So these are the coefficients of f, and we have 3 slack variables. So we will have 2 variables and 3 slack variables in this matrix. And you notice that we have here I4. So this is actually the initial simplex matrix for this problem. We have 2 negative values, so it's not complete. In fact, it is the initial one. So the value of f is 0, and x is non-basic, so its value is 0. Y is non-basic, so its value is 0. S1 is basic, and the 1 is here, so its value is 200. S2 is basic, and its value is here, so it's 400. S3 is basic, and its value is here, which is 350. So these are the values of the variables. It is not complete. Actually, it is initial. Now, determine the pivot element. This is the most negative. So this is the column, the pivot column. Now divide 200 divided by 10, that's 20. 200 divided by 10 is 20. 400 divided by 4 is 100. And 350 divided by 15 is 23.3. So the smallest is 20. So this is the pivot row, and 10 is the pivot column. So pivot entry is 10 in column 1 and row 1. And what are the operations? We divide row 1 by 10. Then when it becomes 1, we use it to make the 4 0, negative 4R1 plus R2, and make the 15 0, and make the negative 8 0. So that's it. Another question. Well, in this case now, all the indicators are non-negative. So this is a complete, this problem is complete and the matrix is a final matrix. Well, I have three inequalities. So these are the coefficients of f, and this is S1, S2, and S3. And I have three variables in this case, x, y, and z. X, let me start by f as usual. The maximum of f is 780 because it's complete. And x is basic variable. Its value is 24. Y is not basic, so its value is 0. Z is basic and the one is here. Its value is 21. S1 is basic and its value is 16. S2 is non-basic and S3 is non-basic. So this is part A. Part B, yes, it's complete. It's a final answer. Okay. Indicate the solution is complete. Yes, it's complete. So there is no C in this case. Well, here, this is not a final matrix because we have -3, -3. So the values of the variables are f is 150. We have three inequalities. So this is f. These are the coefficients of f. And we have three slack variables and three variables in this case. So x is not basic, non-basic 0. Y is also non-basic. Z is basic and its value is 12. S1 is basic and its value is 4. S2 is basic and its value is 6. S3 is non-basic and its value is 0. B not complete because two of the indicators are negative numbers. Now C, part C, we have two choices actually because we have -3 and -3. So the pivot column could be this column or this column. So let me start by this column. If the pivot column is this one, the first one, then I cannot divide 6 by -3. This is negative, so forget about it. Now just divide 4 by 2, the answer is 2. 12 by 4, the answer is 3. So 2 is the pivot entry. So pivot entry is 2 in column 1, row 2. All right, in column 1 and row 2. And in this case, the row operations would be half row 2, then -4 row 2 plus row 1, 3 row 2 plus row 3, and 3 row 2 plus row 4. Or the pivot entry could be, if we divide now, if we choose now this column as a pivot column, we can choose either of them because they are equal, -3, -3. We cannot divide by -11, it's negative, so we divide 4 by 4, the answer is 1. 12 by 4, the answer is 3. So again, this is the smallest. So the pivot entry is 4 in column 2, row 2. And in this case, the operations would be 1/4 R2. Then -4 R2 plus R1 and 11 R2 plus R3 and 3 R2 plus R4. And that's the end of this kind of problems. Use the Simplex method to maximize the given functions. Assume that all variables are non-negative. So now we solve a complete question. So we start by introducing the slack variables. Rewrite the objective function. Set up the Simplex matrix. Coefficients of S1, coefficients of S2, coefficients of F, and the right hand side. This is the Simplex matrix. This is the most negative. 50 divided by 5 is 10. 35 divided by 7 is 5. So this is the pivot entry. Now I will divide row 1 by 7. 35 divided by 7 is 5. And I will write the other rows without any change. Now this is a step in the middle because I needed to do the other step, but it's not a Simplex matrix yet. It would be a Simplex matrix now when I make y, in this case, basic variable. We are not going to change row 1. We will use row 1 to change the other rows. So this is the pivot entry. So negative 5 R1 plus R2 and 10 R1 plus R3. Now notice that these are zeros, so any numbers below them will not change by these two operations. Let us do this operation. Negative 10 plus 5, that's negative 5. Negative 5 plus 5 is 0. Negative 5 over 7 plus 0. And negative 25 plus 50, that's 25. Let us do the next operation. 20 minus 3 is 17. 10. Yeah, 20. 10 times 1 is 10 minus 10 is 0. 10 over 7. And 10 times 5 is 50. Now this is a new matrix, and it's immediately a final matrix because all the indicators are positive. So the maximum of F is 50 at, now X is non-basic, so it is 0, and Y is basic and its value is 5. So this is the answer of this problem. I can just say like this, no need to give the values of S1 and S2. If you want to give them, it's okay. To check my answer, if I put y5 here in the objective function, I should get f equals 50 and x 0. And that's correct. 0 plus 50 is 50. So actually, this is a corner point. And this is the answer of the problem. Another question. Okay, we change first, we introduce the slack variables. We have 3 slack variables in this case because we have 3 inequalities. And rewrite the objective function. All right, let us set up the initial matrix, coefficients of x, coefficients of y, S1, S2, S3, F, the right hand side. This is the initial Simplex matrix. This is the most negative. I cannot divide by -1. So 10 divided by 1 is 10. 15 divided by 3 is 5. So this is the pivot entry. Now I will divide this row, row 3, by 3. This is the first row, the second row without a change, and now the third row. Divide every element by 3. 15 divided by 3 is 5. And the last row as it is. Keep in mind that this is the pivot entry. Good. Now we use it to make all other numbers in the column 0. So here negative are 3 plus R2. Here are 3 plus R1. And here 2 R3 plus R4. And I will have a new matrix. The third row is as it is. And wherever there is a 0, there is a 0 here. So I will write everything above and below without change. So there is a 0 here. And there is a 0 here. Good. And now let us use the first operation. 1 minus 1, that's 0. 1 over 3 plus 1, that's 4 over 3. 1 plus 0 is 1. And 5 plus 2 is 7. The second row. -1 plus 1 is 0. -1 over 3 plus 6 over 3, that's 5 over 3. -1 plus 0 is -1. -5 plus 10, that's 5. And now the last row, 2 minus 2 is 0. 2 over 3 minus 3 over 3, this is -1 over 3. 2 plus 0 is 2. 2 times 5 plus 0 is 10. And this is the second matrix. And it is not final because there is a negative number here. Now divide 7 by 4 over 3. The answer is 5.25. Divide 5 by 5 over 3. The answer is 3. Divide 5 by 1 over 3. The answer is 15. So this is the pivot entry. So we start by multiplying the second row by 3 over 5. And then we will have the following, not matrix, just something in between. The first row, no change. The second row, 0, 1, and this is the pivot entry, 0, 3 over 5, negative 3 over 5, 0, and 5 times 3 over 5 is just 3. The third as it is, the third row, and the last row, the objective row, as it is. And now we use this one to make all other numbers in the same column zeros. So negative 4 over 3 R1, R2 plus R1. Negative 1 over 3 R2 plus R3. 1 over 3 R2 plus R4, and we will have the new matrix. So the second row as it is. Notice that this is 0, so all the numbers will not change in the same column. This is also 0. This is the pivot entry. This is also 0. Good. Let us finish the first row. Negative 4 over 3 plus 4 over 3 is that's 0. Negative 4 over 3 times 3 over 5 is negative 4 over 5 plus 0. So it's negative 4 over 5. Now negative 4 over 3 times negative 3 over 5 is positive 4 over 5 plus 5 over 5. So that's 9 over 5. Negative 4 over 3 times 3 is negative 4 plus 7, that's 3. Now the third row. Negative 1 over 3 plus 1 over 3 is 0. Negative 1 over 3 times 3 over 5 is negative 1 over 5. Negative 1 over 3 times negative 3 over 5 is 1 over 5 plus 5 over 5. That's 6 over 5. Negative 1 over 3 times 3 is negative 1 plus 5. That's 4. And now the last row. 1 over 3 plus negative 1 over 3 is 0. 1 over 3 times 3 over 5 is 1 over 5 plus 0. So it's 1 over 5. 1 over 3 times negative 3 over 5 is negative 1 over 5 plus 10 over 5. So that's 9 over 5. And 1 over 3 times 3 is 1 plus 10, that's 11. And this is a final matrix. So the maximum value of f is 11. X is a basic variable, its value is 4. Y is also basic and its value is 3. But Z is also basic. But we don't have Z because we have only 2 variables and 3 slack variables here. So this is the answer of the problem. Another question in which we have 3 variables. Let us introduce the slack variables. You should pause the video now and try to solve the question by yourself. Three slack variables, rewriting the objective function. And now let us set up the initial matrix, coefficients of x. Coefficients of y. Coefficients of z. There is no z in the second, no z in the third. Coefficients of S1, S2, S3, F. Well, S3 is not like this. Yeah, and you have I4 here. And now the right-hand side. And this is the initial matrix. This is the most negative. 80 divided by 2 is 4. 4 divided by 2 is 2. 30 divided by 5 is 6. This is the smallest. So this is the pivot row, and the pivot element or the pivot entry is 2. So we start by dividing row 2 by 2. And we will have the following. Divide by 2. 3 over 2. 1, and this is the pivot entry. Divide by 2. No change in row 3. And no change in the last row yet. Now we use this one to make all of these numbers zero. So a negative 5R2 plus R1. Negative 2R2 plus R3. 10R2 plus R4. And now we obtain a new matrix. The second row as it is. And wherever there is a 0 in this row, we complete the columns as they are. All right. And let us finish the first row. Negative 5, negative 15 over 2 plus 3. Negative 15 over 2 plus 6 over 2, we will have negative 9 over 2. Negative 5 plus 5 is 0. Negative 5 over 2 plus 0. Negative 10 plus 30. The third row. Negative 3 plus 1. Okay, because here we get negative 3. Negative 2 plus 2, 0. Negative half. Negative 2 times half is negative 1 plus 0, negative 1. And negative 2 times 2 is negative 4 plus 8, that's 4. The last row, 10 minus 7 is, yeah, I multiply row 2, sorry. 10 times 3 over 2, that's 15, minus 7 is 8. 10 times 1 plus negative 10 is 0. 10 times half is 5. 10 times 2 is 20 plus 0, so that's 20. This is not a final matrix because we have negative 4 here. But these numbers are zeros, so immediately the pivot entry is 4. And I divide R1 by 4. I have negative 9 over 2 divided by 4. It would be negative 9 over 8. 0. 4 divided by 4 is 1. 1 over 4. Negative 5 over 2 divided by 4 would be negative 5 over 8. 0, 0. 20 divided by 4 is 5. And the other rows without any change. I hope I did not do any mistake up to here, because you see it's a lot of calculations. All right, now the pivot, it is not a matrix yet, so the pivot, this is the pivot entry, okay? So we use it to make all the numbers zeros. Good for us. It is only the last one. So 4R1 plus R4. That's excellent. So in fact, there is no change in the first row. No change in the second row. No change in the third row. And only the last row will be changed, the objective function. So we multiply by 4 and add. 4 times negative 9 over 8, that's negative 9 over 2. We add it to 8, we get 7 over 2. We are using row 1. So we have 0 here, we will have 0 here, 0 here, no change, no change. Whenever there is a 0, there will be no change. 4 times 1 over 4, 4 times 1 plus negative 4, that's 0. 4 times 1 over 4 plus 0, that's 1. 4 times negative 5 over 8 is negative 5 over 2. We add it with 5, we get 5 over 2. And 4 times 5 is 20, plus 20, that's 40. And this is the final matrix because all the indicators are positive, and the maximum value of f is 40 at, now x is not basic, so it is 0. Y is basic and its value is 2. Z is basic and its value is 5. That's, I'll stop here because this is too much, and I'll continue in another lecture. Thank you very much and have a nice time.